So collision means a crash, an accident. Okay, a crash or an accident. So this type of analysis has improved very much because of the technology. Okay, now we can simulate the crashes. Okay, you can run a simulation and see how the crash happened or how it can happen. Okay, and there are different programs and tools available for that. We have one, okay, which checks for the geometric design. Okay, and you can recreate the crash as well. Like you can have an animation which shows you how the crash has happened. Okay, and then there are tools available to analyze the data. Okay, there are softwares available in which you can put the data and get the results. Okay, so what are we looking for? We are looking for the trend in terms of crash types. Okay, which type of crashes are more happening than the other? Okay, have higher frequency than the other. What time of the day is causing more crashes? In which weather conditions the crashes are happening? Okay, and so on. Another thing you can identify from the collision data, collision analysis, is the causal factor, different causes of accidents. Okay, accidents happen because of different reasons, right? Okay, so which reasons are causing more proportion of accidents and which reasons are causing more severity of accident? Okay, so some of the reasons, and you can see all of them are related to the driver. Okay, fatigue, distracted, elderly, okay, disabled, whatever. So based upon that, we can make some recommendations to the policy, for the policy, or for the authorities and so on. So how do we do the data collection? Data collection for the collision is done or should be done immediately after the crash. Okay, so but you know, all crashes are not reported, they are not collected. Okay, so but it should be done immediately, and most of the times then it is through a police report, right? Even if you don't call the police to come and police doesn't come, you report it, right? Okay, you report it to the police. Okay, and then you have to, whatever you have to write there. Okay, there are standard forms available. These forms are digitized. Okay, again going back to the police report which you file for your crash, for your accident, it's an online form, right? And you write on it, this happened, this happened, this happened. I didn't do anything, I was just going straight, honest guy. Okay, and the other person did it, whatever. So there are standard forms on which you write these things, and these forms can be digital or in paper format. Okay, what information should be part of this data? Information about drivers and passengers. Now we are not talking about reporting the accident, we are talking about now analysis. We have to do the analysis later on for the data. Okay, so what data is important for us, on the basis of which we can make some recommendations for the policy, for the government, for the design, and so on. So data about the passengers and drivers, data about the vehicles, data about the road itself. So these three data items must be there. What were the environmental weather conditions at the time of accident? What time of the day was it? How was the lighting? How was the weather? And so on. A narrative describing the accident, how the accident happened. Okay. Okay, we understand, right? You write your story. Doctor, this happened and this happened. Like the stories you tell. Okay. In most of the cases, a sketch can be drawn as well. Obviously, with the digital form, it's much difficult, but a sketch can be is helpful to see how the accidents have happened. Now I remember that now with the digital forms, they used to publish the accident data, okay, in a booklet, and that booklet used to show the sketch. Okay, not for all the locations, like few locations, but it used to show the sketch. This is how the accident happened. Okay, whichever location had more accident, they used to make a sketch of that location and used to show. Okay, but now they're not at least publishing it. Maybe they have it, but obviously if the accidents are reported online, you are not making the sketch, right? You're just saying how it happened. Okay, so it's difficult now. There are many authorities around the world. Okay, and like I've mentioned, they used to have the booklets for Bahrain as well. Even now they have it, and they provide the accident data on request, basically. But there are other authorities which make them online. Okay, so there are some of them mentioned. So they collect the accident data, they put it online. Okay, so that other authorities can use it, people like us can use it as well. Yeah, so this is like a form where you select, okay, whichever is applicable. So which part of the vehicle was hit, you select which part of the vehicle was hit. Okay, what is this? Was there a collision with an object? So you tick which type of object. How was the traffic flow? So you tick how was the traffic flow at the time of accident. So now what was the type of vehicle? You take the type of vehicle. So this is like a standard form, and then you have to just select one of the options. Now you can see, if you look at the information, then you would know and you would recognize that this cannot be filled later on. Okay, there are many things which you will not remember or which you cannot know later on. For example, the weather conditions, you cannot know. Okay, even the road condition. Maybe there was a pothole there earlier, now it's removed, or they have patched it up, so you don't know now. Okay, so that's why immediate reporting of the data is very important. Okay, the type of collision. The first type of collision is what? See how creative we are. First type of collision is not a collision. Okay, but basically they mean the not a collision with another road user. Non-collision means no other road user is involved. There's only one stupid guy who is doing this. Okay, so ran off the road towards the right hand side, left hand side. Okay, hit the guardrail or something, and these things. Okay, collision of motor vehicle with one of them, or collision of two or more motor vehicles, and then in this case, then you write how did they collide with each other: rear end, side on, angular, head on, and so on and so forth. Okay, we have the injury codes. This depends upon the severity of the collision. This is called type of collision. This is called severity of collision. Okay, this deals with how the accident happened. This deals with what happened because of the accident. Okay, this is how, this is what happened after. Okay, so the first one is killed or fatal crash. So the accident happened, and what happened then? Someone died. Okay, then we have the next one, which is A. I don't know why I say, but it's A. Okay, a person had a very serious injury resulting in having some disability. Okay, so he could not walk himself to the hospital or so on and so forth. And it's not fatal. Okay, the person survived, but the injury was so severe that he could not get to the hospital himself. Okay, then we have B, which has not serious injury, but it's visible. Okay, not serious injury, it's visible. You can see the cut, you can see the blood, but okay, or the scratch or whatever, but the person is still, he can stand, he can walk and so on. Then we have the type C, your type. Okay, the one for which you bring the medical excuse. She is busy. Type C. There is wrong. What is wrong? We don't know, right? Okay, so that one. Okay, you go to the doctor. Doctor, I have a headache. Okay, or I have a stomach ache. Okay, why I don't know. The doctor says I don't know. Okay, they say, but since I have come here, give me a medical certificate. I can go. Okay, fine. Something for the society, benefit of the society. That one, okay. I have something. Okay, I have something. I have an injury. Nobody can see it. That one, okay. And then we have no injury. Okay, so no injury is called, or also called as, property damage only. Okay, property damage only, meaning damage to the car, obviously, damage to the any other object as well, but there is no injury. Okay, so you can see here that we have K, A, B, C, O. Okay, so that's why it's called as a Capco scale or a Fabco scale if you take the first one as F. Okay, so in Bahrain they don't follow this one for reporting. Maybe they have their own data. They don't follow. They follow these ones. Okay, so they have the fatal, and then they have the serious injury, and then they have these two as slight injury. Okay, property damage is not written. Obviously, they have the data as well for property damage. Okay, so you can add one more, but you can see here these two, not these two. Yeah, these two are just mentioned here. There's only one category of B and C. So it can happen. It can happen. The local authorities can decide that how they want to maintain their data. Okay, but this is as detailed as you can get. So detailed, we have 5 categories. Okay, you can merge some of them. What are some of the errors which is found in the traffic accident? Unreported collisions. Like I showed you in the last table, property damage is not reported there. Okay, so these unreported collisions are basically a big part of the data. Okay, most of the accidents are property damage. Injuries happen less often. Okay, and from this part only few are reported. Okay, from this big part of the accident data, only few of them are reported. Only we have a car which has seriously been damaged, then it is reported. But accident is because of a problem, right? So when the accident is not reported, the problem is hidden. That's what we are talking about. Okay, so this is the problem. Incorrect or incomplete location. Okay, so the accident happened here. Accident happened here. Okay, sometimes I say the name of the highway, you don't know where it is, and you are born in Bahrain, right? So this can happen. So the person reporting it does not know or does not mention the correct location, the exact location. So obviously the accident happened near the intersection. You are saying it happened on which highway is this? What's the name of this highway? Sheikh Khalifa bin Salman. So you are saying it happened on Sheikh Khalifa bin Salman highway. Okay, it happened near the intersection. Sheikh Khalifa bin Salman highway is 10 kilometers long. Okay, so this type of problem. Severity is changed after report is filed. Reporting is done directly after the accident. Okay, maybe the person then experienced some other symptoms. Maybe so there was some damage, internal damage. It happens, internal bleeding. Okay, or some shock to the head which has after effects. Okay, so it can happen. The collision type is incorrect. Okay, collision type was how the accident happened. Remember how the accident happened. Okay, so maybe the accident happened between 2 cars. You report it as 1 car and the barrier or something like this. The roadway characteristics may have been reported incorrectly. There were 3 lanes, you reported 2 lanes. There was a curve, you did not report it. Something like this. Now, collision, even if you take the data of one year, it's not like you will find hundreds of collisions, hundreds of accidents. Okay? And what if I take the data of 1 week? Maybe 0. Okay? So collisions happen randomly. Okay, so to have some data on which you can do the analysis, have enough data to do the analysis, we don't take data for less than 1 year. Less than 1 year is like, it's not considered at all, it's no data. Okay, but to make it more appropriate, we prefer 3 years of data. Okay, because in 3 years you can see the changes as well. Okay, so it's per year at least 3 values. Okay, for collision analysis, now we cannot do collision analysis for the entire road network. Okay, now Bahrain is a relatively smaller country. Even for Bahrain, you cannot do, you were there in the IRAP, right? Okay, so even that, in that program, they are just doing the ranking of the roads, right? Okay, but even in that program, they are not doing it. I don't know if they have already started or not. They are not doing for the whole road network now. Maybe it is done in stages. Okay, but the first stage is never to do it for the whole network, because it will cost you a lot. It will take a lot of time. Okay, you have like thousands of kilometers of road and thousands of intersections. Okay, so doing this analysis for the whole road network is not possible, even for a small country as Bahrain. Okay, so you have to pre-screen. You have to select. Okay, so pre-screening means selection of the sites on which you will do the analysis. Okay, so how do, what are the factors because of which we have to pre-screen? There are certain programs, like IRAP is one of the programs, which the department is trying to adopt. Okay, so you may select some site according to those programs. So maybe the department is focusing on signals. So then sites which have signals become automatically your part of your analysis. Okay, so one thing is the priority of the department. Okay, then the hazardous locations, the location which have more accidents, obviously they should be there. We have, why we are doing this? Because the funding, as I already mentioned, funding time is limited. Okay, what is our aim? To reduce the number of crashes as much as possible. Okay, our aim is to reduce the number of crashes as much as possible with these limitations. With these limitations, how much we can reduce the number of crashes? The collision analysis can be done for spots or segments. So a spot is like a point. Okay, for example, an intersection is a spot. Okay, and segment is a segment. Okay, segment has longer length. Okay, you can select a spot which is part of the segment. Okay, you can select a small part of the segment and you can term it as a spot. Okay, for example, any site which has a length of less than 0.2 miles will be considered as a spot. Whether it's an intersection or not an intersection, doesn't matter. But the length of this site is less than 0.2 miles, it will be considered as a spot. Okay, so a spot can be a curve, a spot can be a bridge, a spot can be a ramp, a merging, diverging, whatever. Okay, but it is shorter. Okay, and segments are longer, usually from 1 to 2 miles. Okay, what methods we can use for pre-screening? I told you what pre-screening means. What? Selection of the site. So selection of the site can be done by some of these, one of these methods, or maybe more than one of these methods. They are not all the methods. There are other methods as well. Okay, there are other methods as well, but we will be going through only these ones. The first one is collision frequency. Frequency means what? We have bus frequency, right? Airplane frequency. Frequency means what? Repetition, right? Repetition in terms of time, right? Okay, so collision frequency means selecting sites on the basis of collisions per unit time. Okay, whichever has higher frequency of collisions per unit time. Okay, so this side has 10 collisions, this side has 5 collisions. Okay, but for this side I collected the data for 10 years. This side the data is only for 1 year. So this is 10 upon 10 and this is 5 upon 1. Which one has more frequency? 5 upon 1, right? Okay, so in this way. So it's a very easy method. Okay, you just take the number of collisions, divide by the time. Okay, it's very easy, no calculations, no great calculations involved. Okay, and you can focus on particular severity or type of crashes. Okay, like just before this section, we are talking about a project, and we are talking about only because they are designing something for the pedestrians. So they just looked at the pedestrian crashes. How many pedestrian crashes at that location? Okay, so they are, let's say they are trying to build a new, the bridge, the footbridge, okay, the pedestrian bridge. So then you can see the frequency of pedestrian crashes only. Okay, so you can limit the frequency method to a specific type of crashes. But this method, all the methods have a problem. Okay, everything in this world has a problem, right? All the methods have some problem. There are advantages, disadvantages. Advantages is very easy, no great calculations involved, and anybody can understand very easily. Okay, but the disadvantage is that it is biased towards sites which have more traffic. Accidents happen. We are talking about road accidents, right? Road accidents are happening because of traffic. More traffic means more accidents. Okay, so even without having the frequency, I have 2-3 sites, and this site has more volume. Eventually, it will have more accidents, right? Clear? Okay. So it goes towards that site. That's why we have the collision rate method. Okay, so collision rate is calculated per unit vehicles. Okay, collision is then accident, not per unit time. Frequency was per unit time, right? This is per unit vehicle. Okay, what are the units we'll talk about? Okay, so it's per unit volume to take out the disadvantage of the previous method. Previous method had this disadvantage, right? Where we have more volume, we have more frequency, but the frequency was, the volume was not considered there. Okay, so this method calculates per unit volume, so that volume is already part of the calculation. So how do we calculate the crash rate? This is the equation given here. A is number of accidents you have. T is the number of years for which the accident are collected, and V is the volume. Okay, and 365 is 365, right? So the accidents are, because we have the accidents reported. Okay, so we are now dividing by the number of days we have, total number of days. 365 into number of years will give you total number of days. Why we are doing this? Because of V. What is V? Okay, so this is for how many days? No, this one 1 day. This is 1 day, right? Average annual day. This is for 1 day, but the accidents are for all days. Traffic is 1 day. The traffic we are putting in the equation is for 1 day, and the crashes are for all the days, total number of days, right? It's not crashes per day, right? Total, right? This is total. So traffic should also be total. So that's why this will give you total traffic. So if you collected data for 5 years, the average traffic in those 5 years is, but I don't want the average, I want total. Okay. So this is if you are doing it for a spot. Okay. And this is if you are doing it for a section. Okay. So what did we add here? Length of the section. Okay. Because the spot is very small, so length is almost negligible. We don't add it. Okay. But in in the section, then we add the length as well. Clear? Okay. And what is this 1 million now? Tell me. What is this 1 and 6 zeros?
Seconds barrier. Seconds barrier.
Seconds barrier? Where is it? Yes, anybody?
Maybe like a number.
It is a number.
Seconds.
It is a number. 1000. It's a number. Yes. Yes. Big number. Yes. But it's a number. Maybe like a number. What is this?
Maybe lucky number. Lucky number.
Lucky number. Okay. You can take some of the zeros. Yes. What will happen now? We said what? Accidents. Okay. Accidents are very rare, right? So in 1 year you may have like 10, 15. And what about this number? Very big. Okay. So what is this now? This is for reducing or increasing the significant figures. Okay. This is for increasing the significant figures. If you don't have this, your answer will be 0.0000 something, 10 to the power minus 6 or minus 5 or something. So this is for the increase of the significant figures. So we have, now this will make it what? It will not be accident per vehicle. It will be accident per how many vehicles? This is how much? Million. Okay. So this will give you accidents per million vehicles. So collision rates are calculated per million vehicles. Okay. So I told you every method has a problem, right? Every method has a problem. This method also has a problem. Problem is with V. The previous method has a problem that wherever there is more volume, the frequency will automatically get higher there. Okay. But in this method, the problem is reverse. Where we have less volume means what? V will be less. So rate will be up. Okay. So maybe you have a site where you have 10 crashes. And you have another site which has only 2 crashes. The one which has 10 has a volume of 10,000. The one which has 2 has a volume of maybe 1,000. Okay. So there's already a difference of 10, there's already a difference of 10 in the volume. Power of 10. Okay. So let's consider the easier case, 10 crashes, 10 crashes. This one has 10,000, this one has 1,000. Okay. So obviously this method will show the rate of this side to be much higher than the other side. Okay. But the real number is the same. Okay. So it can be used with collision frequency. So you can use both the methods together. You calculate frequency and you calculate the rate as well. And then you see which one is higher in both of them. Okay. That one had a problem with high volume sites, right? This one had a problem with low volume sites. You can combine them so the problem can be solved. Or there is another method given here. It is related to the frequency, which is have a minimum of the frequency, which is what they do in Bahrain as well. They have a minimum, like if the frequency is more than 6 or 6 or more, then they consider it to be dangerous. Okay, so there is already a limit of frequency. So I will compare the rates, but only for sites which have frequency more than the limit. Okay, so frequency can be used as a limit, and then the rates can be compared. Okay, State Department of Transportation has a budget of $2.3 million. Okay, for a rural sport safety program. Okay, so in an area they got the funding of $2.3 million, and to improve the sites. 4 divisions are submitting the proposal. Okay, for 2 intersections each. Okay, so 4 divisions, each division has 2 intersections, total 8. Okay, and they already calculated how much budget they need on these intersections, and if they do this improvement with the budget, how much reduction in the frequency you can have. Okay, so the budget requirement and the expected effect improvement is also given here. Okay, yeah. So which sites should be recommended for funding here? Okay, on which sites this funding should be distributed? Funding is limited. Okay, and if you add all of them, it will be more than 2.3 million. So all of them cannot get the budget. Okay, so we have to decide. Okay, and we will decide on the basis of collision rate. Okay, so for each of these sites, we need to calculate the collision rate. Okay, now all of them, remember, are spots. And which type of spots? All of them are intersections. Okay, so first thing we will do is we will calculate the total volume. Okay, so site 1, 2, 3, 4, 5, 6, 7. Okay, first of all, we will calculate V. V means total volume. Intersection has 2 roads, right? So you have to add the volume for both the roads. Okay, how much is it? Tell me.
11700.
Next.
750. 6250.
Next.
9000. 9250. 9750. 7950.
9050.
Okay, now I can calculate the rate. So the rate was the number of accidents you have. For the first one, it is 25. Okay, multiply by 10 to the power 6 for the significant figures. Okay, divide by the 365 because it is per day, the volume is per day. The data is for 3 years. It's written here. The data is 3 years. So multiply by 3, multiply by the volume you have. So how much?
1194.
Okay, so now you know you have to take the number from this column and the volume from this column, everything else remains the same. So this is now accidents per million vehicles.
2.56.
4168.
3.55. 2.37.
3193.
3.22.
2122.
Okay, now we have to distribute the funding. We will go with the rate. The highest rate is this one, right? So this one should be selected. If you select this one for the funding, then how much funding they need? It's site number 3. Number 3 needs 480,000. Okay, you have budget of 2.3 million. So obviously we have something left here, right? Okay. So out of okay, I spent this much. Okay, so obviously I have more.
Million, 820.
Correct.
Dharani.
Yeah, we are still doing it. Okay, so this one done. Then which one is the next one?
3.9.
3.93, which is site number 6. Okay, so 6 requires how much funding?
800.
Okay, then which one? This one, right? 3.55, site number 4. Site number 4 requires how much?
320,000.
Okay. Now tell me how much remaining?
700.
700,000. Okay, which one is the next site?
3122.
3.22, site number 7.
400.
And how much do we have? We can do it, right?
700 minus 400. Remain 300. For 300, we can only cancel the number 2.
Yeah, we can
Which
also
one?
select
Select number 2.
We can select number 2. Is it coming or we just selecting it? Is it coming as well, right?
Yes.
How much to? How much left?
20,000.
20,000. Enough for a party, right? We have so many accidents, right? Okay. You can do some, like I already mentioned, there are programs available. Okay. Anybody taking operation research? Okay. Why? Okay. So this is the type of problem you can apply the operation research methods on. Okay. We are trying to minimize what? We are trying to minimize
Number of crashes.
number of crashes. Okay. And we have to, so this is our limitation, right? Okay. So the total cannot be more than this. Okay. So they call it, I forgot now. But you need some constraints. Yes, constraints. Okay. So minimizing number of crashes, the constraint is the budget, and then you can see, so it will give you the best combination. So you can apply some method on it so that even 20,000 is not left, all of it is, because right now what we did, we just looked at this one, but we did not consider the percentage of reduction. Okay, maybe these sites that we have selected, when we apply or we spend the budget on it, maybe the total number of crashes are reduced by only total, let's say, total 40% of the total, maybe. Okay, but maybe there are some other sites, if you have selected them, if you put these budgets, for example, if you take the budget from here, maybe put it here, because you may see a better reduction. Okay, for example, you can see it here. We selected 3, right? No, we didn't select. We selected 3, and which one? 4 as well, right? Which one has higher? We did not select, remember, see, we did not select 8.
So, the rate.
Huh?
The rate not higher.
Yeah, because of the rate. But we don't look at this number. The rate is not higher, but it has more impact. So you can spend 300,000 here, okay, or 280,000 here. Which one has more impact? Okay, we did not do this because we cannot. Then you are looking at the combination, so we cannot do it in this simple way. Okay, yes, Now you have only 3000 left in the end, like we had. Then for one of the values we can see now. Okay, but you can have the whole problem solved using operational research method. Jinan will do it for us. Okay.
Why we stop until
Huh?
why we stop till 20,000?
Didn't stop. Where will you put 20,000?
خلصت الفلوس.
How BJ about?
Huh?
Remain 20,000.
Yeah. Where do we put
شو
it?
تسوي فيه؟
What?
ما في شيء تنشف.
Okay. They're obviously. They're the guys you don't want in your department.
No boss. We don't.
He is the guy who will take this 20,000 and give it back. Okay. The next method we have is rate quality control method. Okay. So we had a seminar on quality control as well. Huh? Okay. So in quality control method we are using some statistical tests. So we are not just comparing between numbers. Okay. So if you look here, we have 3.55 and we have 3.93. Suppose if your budget was less than this. Okay, suppose your budget was less. Okay, then is there much of a difference between these two values? Not really, right? Okay, so for example, if you had to select only one site, then which one would you select? This one, or if you look at this one and the next one is what? 3.93. Is there a very significant difference between these two sites? Okay, we cannot decide based on these numbers. So that's why we have the rate quality control method. Okay, so these marginal decisions can be taken through statistical tests. There's an equation we have to follow, there's a method we have to follow, and the method will tell us if the difference between the two sites is considered significant or not. Is it really high or just two random numbers? Okay. This method is applied to crash rates, the one which we used in the previous method as well. But we will not apply out on the numbers, we will see the whole distribution of data. Okay, there is an assumption behind this method, which is that the accidents follow Poisson distribution. Where else did we study it? 1 or 2? Huh? In the first one, okay, we said traffic flow also follows the same distribution. Okay, so what is this method? The rule of this method is this one. Okay, you calculate the rate at your site. Your site could be a spot or a segment, and then you compare it with a critical value. If the critical value is higher, your rate is lower, your site has no problem. If the critical value is lower, your rate is higher, your site has a problem. Okay. So the problem is, how do we calculate the critical rate? This is the method to calculate the critical. Okay. Average rate, RA means average rate. M is, where is that? Traffic volume during the analysis period in millions. Okay, 10 to the power 6, like we are using for the rate. Okay, million means 10 to the power 6. K is a number which depends upon how much distribution you want to cover. We want to cover 90%, 95%, 99%. Normally, we try to cover 95%. Okay, this is called as, yes, our confidence level. Okay, so if I cover 95% of the distribution, I'm 95% confident about my data or about my answer. Okay, so there's an error chance of 5%. If I take 99%, I'm 99% confident about my result. I have a 1% chance of error. So this depends upon how much error you are allowing, tolerance level. Okay, error or tolerance level. So K values are given here for Poisson distribution. And RA, what was RA? Average rate, and M is total volume in millions. Okay. And again, because we said the rate is biased towards the low volume sites. whichever site has low volume, it will have higher rate. So this method also has the same problem. Okay, so we have a problem, we have an example here, we have a narrow bridge, okay. The bridge has small length, so that's why we are considering it as a spot, okay. So it doesn't matter whether it's an intersection or not. So they want to see if there could be some safety treatment done there or not. We have a total of 14 collisions in 4 years on this site, on this bridge. Okay, the average annual day traffic in these 4 years is 1,000 vehicles. They also collected sample of other bridges in the same area of the same type. Okay, and they calculated their rate as well, and their rate was, so the average rate is given. Okay, and they want to see if the collision rate at this site goes above the critical value or not. If it goes above the critical value, they will do the safety implications here, otherwise not. What is their confidence level? 95%. Okay, so I will calculate the critical collision rate. Okay, so first of all, I need the rate of collisions at my site. Okay, my site has 14 collisions, multiply by 10 to the power 6. Okay, it's a data of 4 years. So 4,365 multiply by the volume, average annual day traffic, which is 1,000. No, sorry, this is the rate, this is the rate of my site. R. Okay, so how much is this? Okay, now I'll calculate R critical. So RA is the average rate, okay, which is how much? 0.6. 0.06? 0.6. Okay, then we have 0.5 divided by the million entering vehicles on my site. Okay, so my site has 1,000 in 4 years. Okay, and to convert to million entering vehicles, 10 to the power -6. Okay, plus K. They gave me 95% confidence level, so K is 1.645 square root 0.6 divided by this whole thing.
So 10 to the power 6 or -6?
-6, right? You are dividing with the volume, right? To convert to millions. Two? 0.6 plus this whole thing, right? 2. Anybody else? What? To convert to millions, right? We need millions. We need volume in millions. 2. Okay, so the critical rate is 2. Okay, and our side we have 9.6, much higher than the critical rate. Okay. So why are we not comparing with the average directly? Average was what? 0.6, right? Okay. So why did we compare 0.6 with 9.6? Okay. Because if you, for example, this is 0.6. Now 9.6 is very high. No problem. What if your site had 1? So average is 0.6 and your side has 1. Is it really a big difference? We cannot say. So that's why we have the rate quality control method. Now you can confidently say that your site has a problem. Okay. So this critical rate gives you like a range of normal sites, not a number. Number is this one. Okay. So this converts into a range. Okay. A range of, so 95% of the normal sites are in this value. Up to this value is considered 95% normal. Then above that is the problematic one. Clear? Any questions?